Video we'll be learning about particle motion, where we can determine the velocity of the particle and the acceleration by just looking at the original function. For velocity, we can look at speed. Speed is always positive since it always has an absolute value. However, if the question just asks for velocity, it can be positive or negative. So for acceleration, it's the rate of change of the velocity or of the first derivative. So by getting the second derivative, it can help us determine the points of inflection, which is when the original function starts to slow down or speed up. Alright, now let's try one. So the position moving along the number line is given by this function right here, and where t is time in seconds, the particle moves both left and right in the first 8 seconds. So that's just the interval from 0 to 8. What is the position at 3 seconds in the interval 0 to 8? So alright, let's try this. So it says, so for this, all we have to do now is just plug it in. And it's asking for at 3 seconds. So 1/3. Which will give us 27/3 minus 4/9/3, which will equal 6. So if you look at the graph, it'll tell us that at 3 seconds, the position of the particle will be at 6. So it'll be right here. So that's what basically the first original function will give you. It just give you the position, but nothing more. It won't give you the velocity or the acceleration. Okay, the next equation I just asked for, and the next problem I asked for is what is the velocity at 6 seconds? So from the interval 0 to 8. So for this, we can't just plug it in because that'll just give you the position again. So what we have to do this time is get the derivative of the function. So do the derivative. We'll give you 11 plus 8t, and minus, okay, and that'll give you t squared, and it's asking for at 6 seconds still. So let's plug it in. Minus 8 and 6 plus 11, which will give you 36 minus 48 plus 11, which will give you ft equals -1. So at 6 seconds, for the derivative, the function will look like this. So it will be -1. But so if we look at it on this graph, we'll be able to see that at 6 seconds, it will be 1. So actually -1. So that's what the position will be -1, but for the original function, it will tell you that the velocity is 1. So at 6 seconds, it will be -1. So the next part it's asking for is also what is its acceleration at 8 seconds as the particle moves in the interval 0 to 8. So after getting the first derivative, we can just go off of that. 2 squared t squared minus 8t plus 11. So get the derivative, 2t minus 8. And then it's asking at 8 seconds. Plug in 8. 2t minus 8. I'll give you 16 minus 8, which will give you 8. So, which will give you 8 meters per second squared, which is the acceleration for the original function. So if we go back to the original function, it will tell you that at 8 seconds, which is right here, right about there, it will be traveling at 8 meters per second squared. And so if we graph that, we would be able to see that its acceleration at 8 is going to be, so it's going to be, should be the same as 8 meters per second squared. So, and that's how it looked like, and I hope that was helpful.